This next topic is about finding the midpoint of a segment. And so I used the numbers from the last example to cook up this problem. Find the midpoint of the line segment connecting these 2 points, those 2 points. Okay, now I want to go about this before I work this specific problem. I want to turn things around a little bit, and I'm going to go about the process of how do you find midpoint. And so I want you to sort of think more in the abstract here for the moment, and then we'll do this problem. All right, so here's, suppose I have a segment connecting these 2 points. And I want to know where the midpoint is, literally the middle. Okay, so how do I find that? Well, we could, I suppose, find the equation of the line, and then try to find a point that lies on the line that is half the distance between these 2 points. I think that could be pretty complicated. So I'm going to kind of cut to the chase here and say, well, look, we can think a lot more easily in terms of horizontal and vertical than we can diagonal. So if I create this right triangle, wouldn't this midpoint be the middle of the base of the triangle? And wouldn't it be the middle of the height of the triangle? All right, now my diagram's not quite perfect, but it's close enough. You get the idea. Does it seem reasonable that this midpoint, if we draw these perpendiculars to these sides, would cut these into halves? All right, well, I hope it does. And so how do we find that? Well, what's nice about this thinking is that I can concentrate on one coordinate at a time. I can concentrate on the x's by finding the middle of the x's, and then I can find the middle of the y's. So what is the middle of 2 numbers? So let's go back to the number line here a minute. Suppose I have on the number line 2 numbers, a and b. What is, and we'll put b on the right, b is greater than a for the purposes of discussion here. So what is the middle of those 2 numbers? All right, now you may know this answer, but what I'm deriving is going to be a way of thinking about a generalization of this problem. Suppose we were interested in, say, the 1/3 of the distance between 2 points, or 3/5 of the way. And so I'm working out a method here that's going to allow us to generalize that notion of midpoint to other kinds of points. So bear with me on this. All right, now the distance between a and b is the absolute value of their difference. Well, if b is greater than a, then it's just a subtraction. That's b minus a. And so if I want to go halfway, then I have to add half of this difference, b minus a over 2. I have to add half of this distance to a, and so this point here would be a plus this distance, b minus a over 2. So if we work through the algebra, get our common denominator here, I've got 2a over 2 plus b minus a over 2. And 2a minus a gives me a. I end up with a plus b on top, and 2 is my denominator. So my midpoint ends up being a plus b over 2. Now, do you recognize a plus b over 2? Where have you done this before? You know, have you ever added 2 numbers together and divided by 2? What would that tell you? That's the average, isn't it? And so the middle of 2 numbers is the average of the 2 numbers. And I think you sort of know this intuitively. You know, if you get a 90 on your first test and 80 on your second test, then what's your class average? It's going to be 85, the middle of them. You take the average, add 2 numbers together, divide by 2, you get the average of 2 numbers. That's what midpoint produces. So rather than give you a formula, and this sort of is a formula, but we also know it as the term average. then rather than give you a formula for finding midpoint, if you just realize it's the average of the coordinates, then you're okay. So let's apply that to this problem up here. Well, then to find the midpoint of this line segment, all I need to worry about are the averages of the x's and averages of the y's. So the midpoint is, and yes, I do expect you to write sentences for me. The midpoint is, and how should we do this? I'm going to take the x's, add these together, and divide it by 2. Take the y values, add those together, and divide by 2. Be very careful with the negatives. So, and I wasn't, was I? Because this is there's a negative 0.4 here, all right? So I'm in a habit of kind of looking over my work. I can catch a lot of those careless errors. Let me just write this a little more clearly for sake of the video. Negative 0.4. There we go. All right, add these together, I get 1.4 over 2. And negative 5.6 over 2. So that gives us 0.7 comma negative 2.8. There we go. So that's the midpoint of that segment. Now I had the diagram up earlier, and I think if you look at that diagram, that midpoint would be look pretty reasonable to you. So I would never discourage you from drawing those diagrams. But when I do midpoint, I'm finding average of the coordinates, and if you remember midpoint that way, then you're okay. So now we're going to end up using midpoint when we talk about circles. For example, the diameter of a circle cuts through the center. So if you have the two opposite sides of a circle on the diameter, then the center is going to be the midpoint, isn't it? So that's one place where we'll see this applied.